Hello everyone. So we have a problem. We have it's a combined mechanical problem, including work per energy and some dynamics. There are two blocks. One is block A and block B. Both blocks are having the same mass, and there is a string, and the tension is same in this string throughout, and we have a massless pulley. So the natural length of this string, which is attached to this point O, is L0, and that is 50 centimeter. And the spring constant or the stiffness of the spring is K, and that is equal to 5 mg by L0. So what actually happens is that by some external source this string is burned. We have to tell that velocity at which the block loses the contact with the plane. So we have to find that velocity. So when the string starts burning, the block will definitely move to this direction. I assume at the point at which the block loses the contact, the distance moved by this block BD, since the block has same mass and the tension is same everywhere, so the block B will also move the same distance D, but in a different direction. So after it moves the distance D, the string will get elongated by some, let's assume by some distance x, and the block moves by distance D. So here I have given birth to two variables. One is the x and another is the d. I will just go and solve these two variables. Okay. After I have solved these two variables, I will just come to know what will be the future course of action. So we have to find velocity. First of all, let us make a free body diagram of this block A. Okay, and we are looking from an inertial frame of reference, so there is no issue. So the block A is like this. The forces acting on the block A are mg in the downward direction. The normal force is in the upward direction. There is tension in this direction, and there is a force called spring force which is acting at an angle theta in this direction. Since this force has two components, one is kx cos theta and one is kx sin theta. Kx cos theta is acting along this direction. N is also acting along this direction, so both the forces are in the upward direction. Not the moment at which it loses the contact, but at the normal moment, these two forces must balance mg. That's why. So that the net motion along y will be 0. According to Newton's first law, if the net motion along any direction is 0, the net force along that direction must be 0. So we are going to write like this. N is in the upward direction, plus kx cos theta is in the upward direction also. These two forces must balance mg, or we can say minus mg equals 0. So let's name this equation first. Now we have a term called cos theta, so we can evaluate it from this. Cos theta will be equal to base by hypotenuse. From this theta, this is L0 is base. Simple trigonometry, it's L0 by x is hypotenuse. Now looking our critical point for which we are looking, जो point हम देखना चाह रहे हैं. The thing is that when it loses the contact with the plane, the normal force must be 0. So this is the physics of the problem. When this will lose the contact with the plane, what will happen? The first thing which is going to happen is the normal force will be 0. Since it will not be on the plane, so there will be no mg, no normal. It will just fall on the ground, and normally ये ground पे रहेगा. जब भी हम ground से कोई चीज को उठाएंगे तभी normal लगेगा. So making this term 0, and then we are left with kx cos theta is equal to mg. We have k as 5 mg by L0. So 5 mg by L0. Then we have x. Then we have cos theta as L0 by L0 plus x. And this whole is equal to mg. This mg and mg will get cancelled. We are left with L0 and L0. 5x by L0 plus x equal to 1. 5x is equal to L0 plus x. So 5x minus x is 4x is equal to L0. And this L0 will be equal to, this x will be equal to L0 by 4. So we have finally found x in terms of our constant term, that is L0. L0 is null, so we can use this 50 by by 4 also, but we won't give values. Then I'm finally getting this. So we have found this x. Now, next thing is we have found x. So from this is a perpendicular, this is hypotenuse, this is base, this is perpendicular. Diagram सही नहीं होगा, but it's a right angle triangle. So from this, from the basic Pythagorean theorem, we will be able to find out this distance d. So this distance d is square root of, we have this. So this distance d is square root of L naught plus x square minus L square. So we're going to write like this: square root of L naught plus x whole square minus L naught square. So x is L naught by 4, as we found it at x equal to L naught by 4. So using this value here, I left this L naught plus L naught by 4 whole square minus L naught. Let's keep the square root here. We'll evaluate this term. So this is L naught square a plus b whole square, L naught square by 16 plus 2 L naught square by 4. Sorry, L naught square by. So this is L naught square by 2. So we left with L naught square plus L naught square by 16 plus L naught square by 2. Writing is like this: L naught square by 2 minus L naught square. So the L naught square will go. Okay, all we are left with this L naught square by 16 plus L naught square by 2. So we'll multiply this by 8 and this by 8. So we're left with L naught square by 16 plus this simple mathematics, 8 L naught square by 16. 8 L naught square plus L naught square is 9 L naught square. So 9 L naught square by 16. Whenever you are going to see the square root of this term, 9 L naught square will be 3 L naught and 16 will be 4. So x is equal to 3 L naught by 4. So x is 3 L naught by 4. D is L naught by 4. Now we have to find the velocity. We will use the basic energy conservation mechanisms. Okay, let us now go to primary physics of the problem. Are we clear on this? Yeah, we need to be clear on the previous part. इसमें कुछ नहीं है, इसमें सिर्फ maths है. Now seeing the physics of the problem, we can see that I have told you this block moves by d, this also moves by d. So ये जो d move करता है, इसमें एक potential energy आएगी mgd. Okay, change in potential energy plus change in kinetic energy is equal to 0. ठीक है, ये सारी एनर्जी किसके बराबर होनी चाहिए? This block has kinetic energy 1 by 2 mv square. This block has kinetic energy 1 by 2 mv square. Both the blocks have same mass, so I can use once. So we can use this twice into 1 by 2 mv square. For both the blocks kinetic energy same है, तो मैं एक ही बार यूज करता हूँ. Plus spring का 1 by 2 kx square. 2 से 2 गया. So mg in case of d you write L naught by 4. It's mv square plus 1 by 2 k की जगह पे हम लिखेंगे 5 mg by L naught and x square की जगह पे x square will be 3 L naught, that is 9 L naught square by 16. Okay, just rearrange the terms and you will get the answer. So mg L naught by 4 is equal to mv square